Okay, in our last video, we talked about LIMS. What did it stand for again? All right, so with that said, we're going to have to talk a little bit more about the analytical balance because that's what this lecture is all about. It's not about LIMS, it's about an analytical balance. So there's going to be some terminology here that we want to discuss in terms of balances. And here are the terms that are going to be some of the most important ones in this particular kind of arena. And the very first one is range. All right, so when I put something onto a balance, I'm going to be measuring grams maybe most of the time. And the range is going to be like how low can I go and how high can I go. That is what the range is going to be. Very often, our ranges will go from something like 0 to 240 grams, give or take a little bit. Of course, most of the time they don't use 0. They'll use 0.0001 or 0.001 or 0.1. I mean, they actually give you a number there, but it will match the decimal readout that happens on the analytical balance. Next up is this thing called a single range. We have single range balances and we have a dual range balance. So what does that actually mean? All right, so single range is pretty common. I think it's probably the most standard one. And the single range means, well, this is what you get. I mean, there's no difference, okay? A single range basically says, here's your minimum, here's your maximum, and this is how many decimals that we will provide you as a readout. So maybe 0.0001. Maybe we've got 4 digits here on this balance, and those 4 digits will stay 4 digits with everything that you put on the balance, and all the way to this low number, all the way to this high number. That's what you're going to get, all right? But then we also have these things called a dual range balance. So what that basically means is that if we look at a dual range, well, a dual range is going to be a gram. And with that gram, you still get a readout, but this is dual, right? And that dual means 2. So there's got to be 2 ranges. I mean, that's kind of what that translates to, right? And the answer is, yeah, you kind of do. So what they'll do is that they'll give you a dual range, and it will say, well, all right, this balance goes from like 0 to 240. Let's just keep that the same. And a dual range will say, well, okay, we're going to kind of give you an option here. If you use this balance that you're going to purchase from us, then maybe 0 all the way up to, who knows, 120 grams, which is like halfway there. Then if you have a mass that falls within that range, dual range, then we will provide you a readout of maybe 4 decimal places. All right, so that's your first range that you're going to get. And then the balance is going to say, okay, if you go over that number, and let's say you go from 120 to 240 grams, well, the balance gets heavier. Your stuff gets heavier. Maybe this balance is not really the best, and it can't provide you that sensitivity anymore. So when you go over that one number, then maybe instead of 4 digits as a readout, the balance automatically goes to a 3 digit as a readout. So that's what we call a dual range analytical balance. Your first range is giving you a number that you can record that goes to more decimal places. Once you go over the number that's stated in the balance description, then you're in the second range. So this is the first one and this is the second one. And in that second range, which is often the highest, that sensitivity goes down. So you go from 4 digits to 3 digits. Or this could be a 3-digit balance that goes to a 2-digit balance, right? Those are the kind of things to look for when you look at these analytical balances that are out there on the market. So single range versus dual range. Next is capacity. So a capacity of the balance is basically the heaviest that it can weigh. So once you go over that number, it's going to give you an error on the display screen, and it's going to say you can't go any higher. Sorry, folks, it's just not going to work for you. Pay us more money and buy more balances that can actually go that high if that's what you want. All right, so capacity, typically in our lab, 220 to 240 grams is what we see most of the time. Next is sensitivity. So what does sensitivity means? Sensitivity is basically the smallest amount of stuff that can get it to change a number. All right. So for instance, we've got maybe this balance pan. Let me clear this out for a minute. So let's say that we've got this balance pan, and on this balance pan, I've got like a weigh boat that I've got some stuff in, right? So on the balance, I'm going to see like 0.5431 grams. That's not sensitivity. 4 digits, that's not sensitive. That is not what that really term means. We use that term sometimes to talk about that realm of analytical balance world, but that's not really the true prim and proper definition. So sensitivity basically means how much would it take for me to go from 0.5431 to 0.5432. Right? I'm getting that number to change that very last digit in the decimal point. Or how much would it take to remove and let me get a reading of not 5431, but 5430. So is it going to be like a tiny little smidge of stuff that I got to take out? Because if so, the balance is very sensitive. It looks for these little tiny changes, these little tiny amounts, and that can make this thing switch that number quite well. Or is it going to kind of take a glomp, a big old spoonful of stuff for me to change that number? Now, the thing here is that if I've got a balance that goes to 4 digits, then it's not going to take very much at all for me to get a change in the display readout. Okay. And then if I take out a big old glomp of stuff off of the balance pan, then, those balances are like 0.1 gram. I mean, that's the readout for those. So that's why we often say my sensitivity of the balance is 4 digits, even though that's not really the true definition. The true definition is how much stuff does it take to change a number on the screen. That's the true definition of sensitivity, but it goes hand in hand. So a 0.1 display readout, well, it probably take a little bit larger stuff than a pink, right, in order to get that to change a number. So in other words, if I weighed out something that was 0.6, chop, and I don't get any other digits after that, I can't just take out a little thing and pretend like it's going to go to a 0.5 or a 0.7. It's just not going to work. So I'm going to have to scoop out a little bit more or scoop in a little bit more to get that 0.6 to change to a 0.7 or to a 0.5. Little tiny changes will not be registered on that balance, and that is the true definition of sensitivity. Next is readability, and this is pretty much the numbers on the display screen. So I've got 3 digits, I've got 4 digits after the decimal. That is what we refer to as readability. Prim and proper, that is readability. And then finally, I get this other term that's called repeatability. And repeatability is doing the same thing over and over, right? That's repeat. I mean, come on now, let's use a little bit of English language. So repeatability means that if I go to this balance and I weigh out something on the balance, I'm going to get a number, right? So let's say I take that off of the balance, and then I'm going to go in and put that same stuff back on the balance and get another number. I hope that these two numbers are going to be the same, right? I mean, it's the same stuff. I've not done anything to it. I didn't eat any of it. I didn't drink any of it. I didn't add anything else to it. But those numbers should be very similar. Well, repeatability is, what if I did that like 4 or 5 times, right? I weighed that same object, or I took the mass of that solid or that liquid over and over and over and over and over. How close were my values? So repeatability is very often regarded as another term, and that other term is called precision. How precise is the balance? In other words, how reliable is it going to be if I take something off and put it back on will it give me the same value as I got the first time? Yes or no? That's repeatability. All right, so when you take a look at these analytical balances, let's say that I'm working for a lab and I've got to order one of these, right? I mean, that could be a part of my job. So I pull up some analytical balance information, and this is maybe what I would see as far as the item listing goes. It's going to describe a little bit about what this balance is going to bring to the table. Here it says capacity, and it says 220 grams. So, you know, if I'm using stuff that's way over that all the time, this is not the balance for me. But for an analytical world, we're way below 220 most of the time, and this is going to be perfectly okay, and that's what we have most in our lab. It looks like a capacity dual range is going to be included with this particular balance. So it looks like the magic cap here is going to be 60. So that means 0 to 60 grams, I'm going to get a 0.01 readout. And then after I go over the 60 grams, so 60.1 grams and above, then I'm going to go to 0.1 milligrams. I go from 2 digits to 1 digit. Is that right? Well, no, not really. Look, this is 0.01 milligram. All right, so 1 milligram is equal to 0.0001. That is what 1 milligram is, right? Okay. Well, how do I know if he's telling me the truth or not? Well, you remember I told you there's a conversion factor that came from that very first video, and I was like, listen, I got a conversion factor for you. 1 gram is equal to 1,000 milligrams, right? Okay, well, what is 1 milligram? What is 0.01 milligram? What's 0.1 milligram in terms of gram? Because gram is the readout that's going to be constantly on our display screen. So let me double check to see if he just told me the truth, because I think he might be a little bit tricky sometimes, right? All right, so 1 gram is equal to 1,000 milligrams. So I'm going to set up something that we call a dimensional analysis problem, or a conversion problem. And the conversion problem here was, all right, well, let's say that I've got 1 milligram. What would be the display readout on the balance, right? Because my balance is going to give me grams, not milligrams, unless we do a setting change. So the way that we do these types of problems is that I take 1 milligram and I put it over 1 as a placeholder every single time, and I bring in a multiplication step, so that's what the little dot is, and then I bring in another division bar, and this is going to set up my proper conversion unit. And I don't worry about numbers, I worry about units first. Milligram is on top. So in these particular types of problems, milligram on top, milligram goes on the bottom. That way these kings can cancel out, right? And then I need to go to gram, because that is what the display readout of the balance is going to be most of the time. Well, what numbers go here in order to do this conversion factor? To convert 1 milligram into gram, I need to know how do they relate to each other. Well, we wrote it up here at the top, right? So wherever I see the gram, there's a 1 that goes along with it. So here's my gram, there's going to be a 1 there. And then here's a milligram unit, there's my milligram unit. So wherever that milligram unit's going to go, I'm going to put 1,000 there. So there's a 1,000. So what I'm going to do is actually go in and pull up a calculator right on the screen so you can see me do this in real time. So in order to solve this type of problem, it looks like I'm going to take 1 times 1, which is 1. And then I'm going to take 1 times 1,000, which is 1,000. And then I'm going to divide those two numbers. In other words, there's a 1 on top, times 1 is 1. 1 times 1,000 is 1,000. And that's what I'm going to key into the calculator. 1 divided by 1,000. And that gives me, he was trying to trick me, right? 0.001. So what that means is at 0.001. That is gram. 1 milligram is equal to 0.001 grams. So if I go back to this balance, it looks like if I go from 0 to 60 grams, I have a dual range of 0.01 milligram. Look at that unit right there, right? It's milligram. That does not mean that my balance is going to read out 2 digits. That means that I've got 0.01 milligram that can be displayed on the balance screen. All right, so the only thing that I'm going to do here is I'm just going to erase. It's the same setup, right? I'm just starting with a different amount there. So 0.01 is what that listing was. There's still 1,000 milligrams in a gram, right? That's not any different. So my answer is going to be different, though. I'm starting with a different value, right? So let's get rid of this so we don't get confused. And I want to know what my display readout is going to be. So in order to solve for that type of problem, I'm going to take 0.01 times 1, which is 0.01, and then 1 times 1,000, which is 1,000. And I'm going to take those two numbers, and now I'm going to divide them. So 0.01 divided by 1,000. And I'm going to hit enter, and folks, there's the number of digits that's going to be on my computer screen or my display screen of the balance. 0.00001. That's going to be 5 digits there. So what that means, and that's what you're seeing up here at the very top, is that if I go up to 60 grams, this balance is going to give me 0.00001, 5 digits instead of 4. But once I go over the 60 mark, I'm now going to shortchange myself because instead of 5 digits, we're now at 4 digits as my display readout. My repeatability, you know, how good are going to be my numbers if I take it off, put it on, take it off, put it on, take it off, put it on. Reliably, it's going to be pretty good to the 3-digit mark. Now, is that good? Well, that's up for your lab to decide, right? So repeatability will be different. It will have different requirements for different fields, but maybe that's okay. The weighing units here, gram and milligram is what we use most often. That's what you will always see on our balances in our lab. But keep in mind, setting changes can happen with the balances. And these setting changes can convert those units into something else. So you can measure out in some of the English units, right? If you don't like grams and milligrams, you can do pounds and ounces and those types of things. Not a big deal. It's just not often used because that's not what we use in a laboratory setting. Next is a calibration type, and it says internal. I'm going to talk about this calibration stuff toward the end of the lecture, so that way you know what those are. But it does look like it has an internal calibration setting. And then finally, the description. And it says, here is the description for our balances. Here's the item number. This is what you're getting. So just double check, and don't be like Tracy Holbrook. Just double check what you're really after and make sure that it's right. If I follow up that listing on a, something like Fisher Scientific or some type of laboratory company, if you look at that particular model, which was a Denver analytical balance, the Denvers will come in different model numbers. So here you see 114 and 214 and 314 and PI 225. Each one of those model numbers are slightly different in their own way. Most of the time, the major difference is the capacity. That will be the kind of the major deciding factor. So a P114 goes up to 110 grams, a P214 goes to 210, a P314 goes to 310, and a PI225 can actually go to 220 grams, but it looks like it's a split. There's a 60 and a 220. So that's a sign that it's a dual range analytical balance for me. If you look at the readability, they're all pretty much the same except for the last one. If you look at the range, well, it goes 0 to 110, 0 to 210, 0 to 310, 0 to 220. Hopefully that makes sense because that's the maximum capacity of the balance. The repeatability, pretty much the same all the way across the board for most of the normal balances until you get to this kind of dual range. Linearity we'll talk about later at a different moment in time, so just forget about that for now. Stabilization time, how often do I have to wait, or how long do I have to wait when I put something onto the balance pan? Typically 3 seconds or under. I mean, these things are very fast. I don't need to take forever and kind of tap my fingers on the balance or on the desktop, the laptop, the lab bench. I don't really have to do anything, right? I mean, it's pretty much instantaneous unless I get a weird, wonky little balance that needs some work. And I get this thing called a pan size. The pan size is just what will hold your stuff. Most of the time, those are pretty standard, and it looks about like 3 inches in diameter. That's big enough to hold most of our weigh boats and containers that we use in a laboratory arena. Down at the bottom, these are the top loader balances. So that's how this table is different than the one up above. If you look at the top loaders, again, I told you top loaders and precision balances, those typically go higher in grams. So 200 gram, 400 gram, 600 gram, 2,000 gram. The readability is going to get shortened. Notice it's 0.001 gram, which is 3 decimal places, not 4 and 5 like the analyticals are. Stabilization time's about the same, 3-4 seconds, give or take a little bit for those balances, not a big deal. The pan sizes are a little bit bigger, and that's because they know that you're weighing more stuff. So weighing more stuff means bigger weigh boats, means bigger containers, and those balance pans need to be bigger to accommodate that information. Next up, what I want to talk about is this thing called drift. What is drift? All right, so remember, I said, hey, we've got this little piece of glass up on top of this balance pan, right? And then we've got kind of this thing on top, and these doors can slide, and the top can slide. Yay! It protects us. Well, if these doors are opened, then we get some air currents beep, that can go inside of that area that we're trying to measure. And that balance is very sensitive. And it doesn't take a lot to get that number to change. Your breath can get that number to change. And the drift is just something that is a bouncy number on the balance. It's never going to settle down. So I'll weigh something on the balance pan, it's a number. And then I take a look at that number like 1 or 2 seconds later, and that number is different. And then I take another look at that number 10 seconds later, and that number is different. So there is a chance that drift is happening. And that drift is causing a change in the display. So how do I know what number to write down, right? Do I write down the number that I see automatically, instantaneously? Do I wait 15 seconds and write that number down? Do I wait 30 seconds and write that number down? Do I go by the balance where it said, hey, listen, stabilization time is 3 seconds. Do I do 3 seconds and then write that number down? Well, drift is a problem that needs to be fixed. It should not be something that you should accept. That's the thing here, right? When you put something onto a balance, it should provide you a number, and that number should not be changing constantly as you're looking at the display. And there's 2 common types of drift. One is just random, which means it can go down and up, down and up, down and up, down and up. That is an internal balance problem that needs to be fixed and taken care of before we use that balance for any purpose. The other type of drift is going to be the constant version. And the constant means it can constantly drift down, lower, 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 and you're not doing anything to it. I mean, you're just looking at it and you're like, this stuff, it keeps going down. What am I doing? I'm not doing anything wrong. How am I losing stuff? And then the other constant version of drift goes up and up and up and up and up. And you're looking at it and you're like, wait a minute, I've got this sample on the balance, and that balance pan is telling me that I'm getting more stuff and I've not added anything. What's going on? That's not necessarily a problem with the balance. It could be, but this constant drift of down and up, this is more for the sample. That's really where we take a focus on first. And then if we can't figure out what's going on with the sample, and maybe there's nothing going on with it, maybe it is the balance. But if I see a constant drift down or a constant drift up, I'm going to look at sample first, not the balance. But if I see random numbers that just get displayed, lower, up, lower, up, lower, up, lower, up all the time, then this probably is a sign that my balance needs a little bit of work. So some of the things that we can do to minimize the drift, what are things that we can do as a user to make sure that this doesn't happen to me in the laboratory? Number one, we want to make sure that the balance is stable. We want to make sure it's on a countertop, not on like a rolly cart, not on something that is not very permanent or something that doesn't have a solid surface that doesn't bend and bow. We want to make sure that the balance is level. So very often there is a leveling bubble that happens on the balance itself, and we want to double check that level bubble, because we want, just like if you're trying to level something at home with kind of a level stick, we got those on our balances as well. Next, make sure that you have them away from any type of window that can kind of get a draft. Make sure that you keep them away from doors that can also create some drafts. Make sure that you keep them away from any type of heat source, radiators, portable heaters, air conditioners, and so forth. And make sure that you keep them away from any type of mechanical equipment. Very often these things can trigger, they can heat up, they have fans that cut on, blow some air currents out. So you just want to make sure that all of that heat and that air current stays away from the balance. And very often it's a good idea to keep balances kind of off on their own whenever possible. Proper use of a balance, now that we're talking about a little bit of this. Number one, you just want to make sure that the pan is clean before you use it. So when I walk over to an analytical balance the day of a lab, I'm just going to kind of eyeball it and spot check it and be like, yep, somebody behind me did their job and they cleaned that balance, and that makes me yay happy. Then number two, I'm going to weigh something out on that balance pan. And we don't have to use weigh boats every single time, right? And the reason for this is weigh boats cause transfer loss. I don't know why this writing pad is so bouncy, but that's why my writing is so awful. So the transfer loss. If I weigh something in a weigh boat and then I take the weigh boat and I transfer that into a container, that transfer step, I'm running the risk of losing what I've weighed out, at least a smidge of it. And not all of it will transfer out of the weigh boat, so some's going to stay behind. And if that's the case, then I've got another problem. So I really like to measure things directly into the container that they need to go into whenever possible. That makes me a much better laboratory personnel. Number three, clean up after your use. So if I'm measuring out some solid powders, make sure they're not lingering behind on the balance pan. If I'm measuring out some liquids, make sure those liquids are mopped up with paper towels or cleaned up in some form or fashion. Don't leave stuff in the balance pan area for someone else to clean up after you. I'm not your mama, and I'm not going to clean up after you either. You're going to have to do it yourself, right? Number four, have a scheduled maintenance plan. So what this means is that either internal or external. All right, so the internal maintenance plan is me. There are things that I can do with an analytical balance to make sure that it stays working the proper way, right? It's kind of like taking your car to the garage. Every 3,000, 5,000 miles, you're getting an oil change, right? That is a maintenance plan that you have built in to something that is expensive that you want to ensure that works day after day after day, year after year after year. So part of that is an internal piece that I need to kind of pay attention to. And the other part is an external piece. And that external piece is called preventive maintenance. Very often, these companies that sell equipment like an analytical balance will try to sell you a preventive maintenance schedule or plan. And the PM contract, that's what we refer to that as, has them to come out to your laboratory facility, and they do calibrations and they make sure that these things are working properly. and you pay them thousands of dollars in order to do that. With all of our equipment that we have in our chemical technology laboratory spaces, that equipment, we do not have preventive maintenance on them. There's no PM contracts on anything. The college really doesn't allow us to have them. So we've got to do that ourselves. But that's okay, because that's thousands of dollars of taxpayer money that would be spent, and we don't really need those heavy regulations that a laboratory would have to go through, right? We just don't. We don't need that. So why waste taxpayer money again on something that we don't necessarily have to have? As long as we know how to do our job the proper way, then we can ensure that our balances are giving us appropriate numbers. And we can kind of adjust for the balance and fix the balance as needed, but we can at least do that internally if we want. So that's where I'm going to stop this video. We're going to have another one, and the other one's going to pick up from here. Like, how would I do this internal piece of an analytical balance, right? What would I do in my own lab to make sure that my balance is giving me the proper numbers that it should be giving me? So that's what we'll talk about in the next video. So we're not quite finished with our balance lecture yet, and that's okay, right? We're taking our time. We're getting to know the balance. Maybe I'm learning some information that I didn't know before, and that's a whole point of this class too, right? It's all of this kind of extras with the cherry on top. So I'll see you in the next video.